Hello Matrix and welcome again. Today we're going to be doing our final proof that you need to know for your Matric Maths paper 2. And this is that equiangular triangles are similar. How do we prove this? Well, we're given two triangles and they're of different size, but they have different angles. And as always, we need to make a construction to start with. And our construction is we're going to draw a line from AB to AC. And I'm going to label this line GH. And the construction is such that AG is equal to DE and AH is equal to DF. So that is my construction. So I construct GH such that AG equals DE and AH equals DF. Okay, so what do I need to prove for these to be similar? Well, I need to prove that their sides are in proportion. So in other words, I need to prove that AB, let's just draw this in green. So we need to prove that AB over DE is equal to AC over DF. All right, so what I'm going to do is I'm going to start with the triangles because these triangles I need to prove are exactly the same. So I'm going to say first my RTP, required to prove. So required to prove RTP, it's a bit big. So required to prove is that AB over DE is equal to AC over DF. Well, if I got these two to be exactly the same, I would simply need to prove that this triangle is in proportion with this triangle, because this triangle would be the same as this triangle. So let's go about doing that by examining the two small triangles. So that's what I'm going to do. I'm going to say in triangle AGH and triangle D, this is an and, DEF. Okay, let's look at the triangles. Well, we know that AG is equal to DE because we constructed it that way. So AG is equal to DE by construction. Then we're going to look at AH, and we can see that that is also going to be equal to DF because of construction as well. By construction. And then finally, we see that they both have the purple dot. So we know that A is equal to D. And that was given to us at the beginning. So I can say, therefore, triangle AGH is congruent to triangle DEF. Well, now that we know that these are equal triangles, we can go about just examining this triangle on its own and seeing if we can get GH parallel to BC, we can use prop theorem that we did in the previous video where we looked at the proof of prop theorem, which states that if these are parallel, then AG over AB is in proportion with AC over AH. So let's see if we can make these parallel. Well, for them to be parallel, let's look at this over here in blue. So this would be an F, which we know would be corresponding angles. So if we could make this a diamond, we could say that GH is parallel to BC because of corresponding angles. Well, we can see that we've got a blue triangle, a blue diamond down at the bottom, and we know that these are congruent. So we can say, because of this congruency, we can say, therefore, AGH, so this is equal to angle E. And also, how did we know that this B was equal to E? Well, that was given to us. So we can say that B equals E given. And so we see that E connects AGH and B. So we can say, therefore, AGH equals B. And therefore now we can say GH is parallel to BC because of corresponding angles are equal. Okay, now that the corresponding angles are equal and the sides are parallel, we can use prop theorem to say that AG over AB, or should I say AB over AG is equal to AC over AH. So that was in green, so let's keep it in green. So AB over AG is equal to AC over AH. Okay, so let's look at this, what we have. So it was AB over DE, AB over, so we've got the AB and the AC and the AB and the AC. So that's almost there, right? So we've got AB, AB, and DE and DF. Well, we know that AG, this is equal to DE because of the whole congruent triangles and also by construction. So we actually proved it. All we need to do is replace DE, AG with DE. So we're going to just do that. We say, therefore, I'm going to do it on this line because I'm running out of space. Therefore, AB over AG is equal, not AG, AB over DE. Oh, we do need to say here, let me just put in here, we need to give the reason here as prop theorem. Don't forget that, prop theorem from the video before. I'll put a link to that video now actually so that you can check out that. And that therefore AB over DE is equal to AC over DF. Okay, so this is already quite a long proof. There are longer versions of the proof where you could say that similarly. Now, this is fine. You'll probably be given a template and asked to fill in, but you could say similarly, if I was to draw, so I've done here with the red, I've made this small triangle equal to this triangle here, and therefore I've proved that these are in proportion. I could also just as easily have said, well, you could make a small triangle here. And so you could compare this triangle with this triangle, and you see that the diamond and the diamond are the same, and then BD would be equal to whatever you made this. So this could be, say, PQ, and you could say BP is equal to DED, and EF is equal to BQ. And you could start by then doing this whole thing, and you would get now these in proportion. So you would get AB and BC in proportion with DE and EF. And you could also do one from this. You could do one as well from here. Okay, so don't worry about that too much. You're not going to be asked a 13-mark proof in the final exam. But just know that you could similarly prove that the other sides are in parallel. But that's good for now, and we're just going to finish off by saying, therefore, let's do it in white. Therefore, ABC is similar to triangle DEF, because that's what we needed to say. Equiangular triangles are similar. So ABC similar to DEF. So that's the final proof. Last two were pretty long, and you might have to watch the video more than once, but hopefully that helped you. If it did, please find the like and subscribe button down below. Click it, share with all your friends and all that good stuff. Help support the channel. I'll keep making videos to help you guys get through your matric. And if you're in grade 11, you'll probably be doing this as well. So yeah, have a great day, and I will see you soon.